The von Neumann architecture, also known as the von Neumann model, is a computer architecture design that uses single shared memory for both instructions and data. It was first proposed by John von Neumann in the late 1940s and still is the basis for modern computers today. In the von Neumann architecture, the CPU reads instructions from the memory one at a time and executes them. This sequential execution limits the performance of the CPU because it must wait for instructions to be fetched from the memory before it can execute them. The Harvard architecture, on the other hand, uses separate memory spaces for instructions and data, which allows the CPU to access both simultaneously. This architecture was first used in the Harvard Mark I computer in the late 1930s and is still used in some specialized systems today. The main advantage of the Harvard architecture is that it can fetch instructions and data simultaneously, which can be led to improve performance. However, it also means more complex hardware to implement, and it can be more expensive. Contemporary processor architectures, such as those in a modern desktop and laptop computers, typically use a combination of von Neumann and Harvard architectures. For example, most modern processors have multiple levels of cache memory, with separate caches for instructions and data. This allows the CPU to access frequently used instructions and data quickly, while still maintaining a single shared memory space for program and data storage. Additionally, modern processors may be used advancing techniques such as pipelining, superscalar execution, out of order execution to perform and further improve in performance. These techniques allow the CPU to execute multiple instructions simultaneously or out of order, which can improve performance by reducing the amount of time the CPU spends waiting for instructions to be fetched from the memory.